Now we will discuss determination of iodine value in fats and oil products. The principle involved in this analytical procedure is the iodine number measures the amount of unsaturation in the fatty acids or triglycerides. So basically what we are doing here is measuring the level of double bonds or triple bonds, or in other words unsaturation in fatty acids in relation to the total amount of fats and oil. So higher is the iodine value, higher is the unsaturation. So it is basically calculated as the amount of iodine in gram absorbed by 100 grams of sample. So higher the saturation, as I said, higher is the amount of iodine that would be absorbed. And for this procedures we would be dissolving this fats and oil into a solvent that would be reacting with iodine, so that iodine would be absorbed and we can calculate the excess amount of iodine remaining in the solution. It's not always iodine that is needed to perform this reaction. We can also use any other halogens. For example, bromine is also used in certain instances where we can calculate the bromine value, and that this bromine is again converted into iodine value, but the reaction remains the same. If you talk about the procedure, we would be using a potassium iodide solution to reduce iodine chloride in the form of free iodine. This free iodine reacts with the starches and produces color, so that color acts as an endpoint indicator, and this is again titrated with sodium thiosulfide using starch indicator. So once the color is changed, we can get to know that all the iodine has been utilized by this reaction. Looking at the procedure, as I said, we are dealing here with excess iodine chloride, so that would act with this fatty acid, and as a result we produce this saturated fatty acid. Here we would get iodine added to the double bond, so this would be converted into a single bond, and then we have this remaining iodine chloride because we have added excess amount of iodine chloride here. Once we have this excess amount of iodine chloride, then we add another reagent, potassium iodide, so that would react with excess iodine to produce potassium chloride, potassium iodide, and free iodine. This free iodine would react with starch and would have a blue color indication. Now we add sodium thiosulfide during the process of titration. So this sodium thiosulfide would produce these two reagents as well as a endpoint of starch titration, which is a colorless starch solution. So if we talk about the formula for measuring the iodine value, it has got blank value minus sample value multiplied by the normality of sodium thiosulfate, and 126.9, this is the molecular weight of iodine here, divided by weight of the sample multiplied by 100. So once we have performed this operation, we would be ending up with iodine value as a digit number that would tell us about the unsaturation of fats and oil that we are determining here. So this was a straightforward procedure for measuring this iodine value. The iodine value can have different application in industry, where we want to know the degree of unsaturation before the hydrogenation process or the refining process. So this information would be useful for performing hydrogenation or refining processes. Similarly, if we have a food that has got fats and oil that has got lower iodine value, that would mean lower unsaturation. On the other hand, this would also mean how much soap is being produced during this overall process. So this tells us about the quantity of soap produced in this industrial operation as well. So this was overall the process for determining iodine value and some of its application in the real life.